And welcome to week 5 lab activity. Today we will be performing an NDVI in ArcPro. So go ahead and scroll down to the activities section on the week 5 homepage. Though the homepages have all the content that you'll need and material for the week. So you should have already watched and taken notes about the lecture material where we learned about image preprocessing and then spectral indices. And then please read the activity content where we have a little background information about NDVI and today's objectives and more background context. So go ahead. The first step would be to download the data, which should be it'll be right here once it loads, but under activities. And once downloaded, you can open up a blank ArcPro map and you can begin by installing the downloaded data. So you can reference week 1, and I believe week 2 or 3, where I show how to download and extract data. We're going to just start without a template for today. And then navigate to the folder where you downloaded the data. So I have my data, I believe, and sometimes I need to reference the Files Explorer to see where it is. Okay, and we're looking for a .tif file, and it's right there. It should be called SLO Landsat Composite. Right click, add to map. And so this is a composite band raster layer that I created for you so that you could just focus on NDVI and the objectives for today. But basically, it's a repeat of week 3 where we downloaded Landsat data, so the individual bands. And so I looked up San Luis Obispo County. I added a filter of no cloud coverage, and I wanted certain months so we could see vegetation. And then I downloaded bands 2, bands 3, 4, 5, 6, and 7. And then I created a band composite, which is a tool that we've used in the past, and I created this composite layer. And so unfortunately, ArcPro by default will call band 1 whatever the top band is in the layer. So for example, band 1 is actually band 2 from Landsat, and I've provided the original data in the lab submittal. So you could see band 1, the original Landsat band was band 2. And then band 2 is actually band 3 from Landsat. And so unfortunately, ArcPro does that, and you can't find that source information. So I provide it for you here. Okay, so you have your composite TIFF layer. And let's go up to analysis and tools, and we're going to look for NDVI. You know what? That's actually not where it is. I forgot. It's under raster layer. Is it, or is it imagery? Sometimes I forget. Here we go. Yes, it's imagery ribbon, tools, and then indices. And here you could see a list of all the vegetation and soils indices that ArcPro provides. So like I mentioned in lecture, there's a lot of different mathematical equations that you can use to kind of analyze your images. But for today, we're going to look at NDVI. For example, like SAVI, SAVI, Soil Adjusted Vegetation Index, and that's really helpful for analyzing soil brightness correction factors and other vegetation aspects. Okay, so let's click NDVI. And by default, it goes band 1 and band 2, but like I mentioned, you have to change the bands to correspond with the original Landsat bands that comprise this composite layer. So I also provide that in the lab submittal. So near infrared band index, let's make that band 4. because that's the near infrared band from Landsat. And then for the red band index, let's make that band 3. Okay, and then press OK. And so now we're creating this NDVI SLO Landsat composite. You should have a gray kind of black-white scale color scheme, and it'll automatically create your new layer. And so now we want to zoom into Morro Bay. It should be further south of the county. You could see the Morro Bay is completely black. And so congratulations, you've now created an NDVI layer by just the click of a few buttons. And Arc Pro is really nice because it makes analyses like that really quick and efficient. But the objective today is to really learn what we are looking at and what this, this image and these numeric values that we will see really mean. And so let's make this a little more exciting and right-click on NDVI Symbology. Let's click a brown to green color scheme. And that will help with identifying some of the features. Brown to blue-green. That should work. Okay. And so the brown is where there is little to no vegetation, and the green is where it's more heavily vegetated. But remember, NDVI is important because it actually puts a numerical value in these pixels rather than some of the other composites like true color and false color composite, which is strictly visual. And so to view a pixel value from this layer, you want to make sure it's selected and then go up to Map and select Explore. And let's zoom in to Morro Bay. And you could see it's really, for lack of a better word, pixelated. And that's because this Landsat data is 30 meter by 30 meter spatial resolution. And so it only sees 30 meters by 30 meters on the ground in every pixel. So this is on purpose because this is the designed spatial resolution. But you can use false color composite layers to reference and kind of see where you're looking at. And so I'll just click a pixel and then we can go over the next step. So I'm going to click the residential area. And I know Morro Bay, and if you don't, I've provided a land cover map that will help you look at different land covers and see where residential areas, where agricultural fields are, where the water is. And so you could see when I clicked on the pixel for the NDVI layer, I get a value of 0.185164. And so that's actually a numerical value for that pixel derived from the mathematical equation of near infrared minus red divided by near infrared plus red, which we learned about in lecture. And so inversely, if I click on the Morro Bay, the bay itself, where I know it's just water, there's actually a negative pixel value. And so that's on purpose. That's because of what the inputs are. And let's also use a false color composite layer to reference. So I'm going to go back to SLO Landsat Composite, turn the NDVI off, and let's go to Symbology. Right now it's band 1, 2, and 3, which we know would be, if I scroll up from on the labs middle, bands 1, 2, and 3. So it's bands 2, 3, and 4 is the stories, but we want to change it to false color composite so we can see those bright reds, which we know means healthy vegetation. And so that would be bands 5, 4. Oh, I think I have that wrong. So 543 is the Landsat, but what does that correspond to here? So that means bands 4, 3, and 2. Okay, so bands 4, 3, and 2, right? And so now we see those bright reds, and that'll help us with identifying the NDVI values. So let's go ahead and turn the NDVI layer back on. And then one tool I like to use with remote sensing is the imagery. And we want to use where is it? Raster layer. There it is. Raster layer, swipe. And then you can swipe down and see where there's bright red. And it looks like it kind of corresponds to the dark blue, but it's best to get the numerical value for that pixel in the bright red. So I'm going to zoom in into an area in Morro Bay that I know has healthy vegetation based on the false color composite. I would say that's pretty bright red, that one. Or let's see over here. So let's see which one is actually has a different value. So then we're going to go back to the map and the Explore. And see, these look the same color on NDVI layer, but what's the value? So that's a 0.44, and this one's a 0.42. So they're actually quite different. And why that is a number of reasons, which I went over in lecture, but that's for you to interpret and continue to look at different pixels in different land covers. So if you go to the lab submittal, the objective of today is to go through the land covers and write down the pixel values and then get an average NDI for each land cover type. And hopefully you'll see a theme happening and then use this information that you're learning to answer the following questions in addition to the lecture material, which would help as well. And so rather than using visual interpretation like we've done the past several weeks, we're now quantifying and using actual numerical values to help evaluate and interpret the satellite images. So go ahead and complete the lab at this point and upload it to week 5 lab submittal.